Hi, this is Ms. Katz, and today I'm going to go over the first half of our study guide for our unit test, end of unit test that we will be having this Friday. So I'm going to start with question number 1, and we're going to go to question number 9 today. We will pick up 10 through 18 tomorrow. So the first question is a division of fractions question, and we're going to start, I'm going to zoom in a little bit so it's a little easier for you all to see. We are going to start with question number 1. Remember that the algorithm for division of fractions is that we actually, instead of dividing, we multiply by the reciprocal. Now, we used KCF to help us remember to multiply by the reciprocal. K represented keep the first fraction the same. Change meant instead of dividing, now we're going to actually multiply. And flip means we're going to take the reciprocal of the second fraction. In this case, that turns it into 14 over 1. Now, I always believe we should simplify before we multiply. And so I'm going to do that because I know that 14 and 7 share a common factor of 7. If I divide by 7 down here, 7 divided by 7 is 1. And 14 divided by 7 is 2. Now I have no other common factors on the top and the bottom, so I'm just going to simply multiply across. 2 times 2 is 4. 1 times 1 is 1, and that means our answer is simply 4. Now, if you didn't simplify before you multiplied, you would have gotten 2 over 7 times 14 over 1. You would have had 28 on top and 7 on the bottom. And if you divide 7 into 28, because remember, we talked about this fraction bar meaning division. If you divided 28 divided by 7, you would come up with 4 as well. So either way will work. I just like dealing in 7s and 14s rather than blowing these numbers up and having to simplify them after. All right, problem number 2 is also a division of fractions problem. But before I can actually use the algorithm, I need to change those mixed numbers into improper fractions. And if you remember, we do that by multiplying times the denominator because I have 9 whole pieces, 9 whole sets. Each set has 4 pieces. So together that makes 36 pieces. I have an extra 3 pieces as well, making 39 pieces when I needed 4 to make a whole. Here I have 8 to make a whole. I've got 2 wholes. Together that's 16, plus the extra one, that's 17 eighths. Notice this is still division. That's a big deal. We haven't done anything yet to apply an algorithm. All we've done is change the close on these fractions so that they look more like what we want them to look like to divide. These are exactly equivalent fractions. They mean the same thing. They're just dressed up a little different so we can work with them. So again, we keep, we change, we flip. We keep the first fraction, we change from division into multiplication, and we flip the second fraction over, making it its reciprocal. This one, again, we're going to look for some common factors that we can simplify. 8 and 4 share a factor of 4. 8 divided by 4 is 2. 4 divided by 4 is 1. Okay? There is no other common factor in this particular problem, so we multiply. 39 times 2, if we don't know what that is, go off to the side. 18, carry the 1. 6 plus the 1 is 7. So we get 78 on top. And 1 times 17 is 17. Now, since that's simplified, that is a perfectly good answer for me. However, you also need to recognize that that is an improper fraction, and we can make it a mixed number. We do that by taking the top number, the numerator, dividing it by the bottom number, the denominator. I know 17 is kind of close to 20, and 78 is kind of close to 80. So I'm going to guess that 20 goes into 80 about 4 times. So let's check that theory. 17 times 4 is 68. I can't put another 17 in there or we'll go over 78. So it was a good guess. 4, making this 68, leaving a remainder of 10. So that's 4 and 10 seventeenths. And again, since this was already simplified, this will be simplified as well. Okay? Either answer is correct, but you do need to be able to recognize both of them. All right, moving on to decimals. This is an addition problem. Remember, I told you with addition, it's a really good idea to make a structure. Now, in a lot of the problems we did for practice, there were only 2 numbers, but it works the same when you have 3 numbers. I'm just going to build my numbers around those decimal points. So 25 goes over here, 19 over here, the 8 and the 3. And notice that 43 goes to the left of the decimals. There is an imaginary decimal sitting right there. We don't need it unless there's something after it, but it exists. If you put that decimal anywhere else, if we had put the decimal here, that'd be $4.30. If we had put the decimal here, that'd be 43 cents. If we put the decimal here, it makes it $43. That's a big difference, especially when you're talking about money. Now, what we need to do here is fill in all those extra holes with some zeros to make it easier to line everything up. 9 plus zeros is 9. 1 plus 3 is 4. 5 plus 8 is 13. Plus 3 is 16. 1 plus 2 is 3. Plus 4 is 7. So the answer would be 76 and 49 hundredths. Okay, question number 4 is a multiplication problem. We talked a lot about how we can get rid of those decimals and not worry about them at the beginning. So let's just pretend that this is our problem. Okay, don't forget that algorithm. 6 times 7 is 42. 6 times 2 is 12, plus 4 is 16. Put a 0 down because we're moving over a space. Okay, we've moved over to the tens place. 9 times 7 is 63. 9 times 2 is 18, plus 6 is 24. When I add, those are the numbers I'm going to get. Now remember, we took those decimals out, but we need to put them back in. The decimals were here and here. That means there's 2 places after decimals in my problem, so we will start at the back, move 2 places in, and our final answer is 25 and 92 hundredths. On to question number 5. This is a subtraction problem. Subtraction works just like addition. We're going to make a structure. Got to line those decimals up. Build your numbers around the structure. Put in your what? Your placeholder zeros to make sure that we know what we're doing. Now this is where it gets a little tricky and you got to pay attention. I cannot take 7 from 0. So I'm going to reach over here and I'm going to take those 10 pieces and move them into the different column. 10 minus 7 is 3. 0 minus 0 is 0. Now, if you recognize that this is really just 10 minus 3, you could put a 7 here. If you don't, you can borrow from here, regroup it. You'll still get 7. So the final answer here is 7 and 3/100. On to question number 6. So we talked about how long division, division of decimals is really just long division. We just have to figure out where the decimal goes. You never divide by a decimal. We always turn it into a whole number. So we do that here by moving it 1 place to the right. Whatever I do outside, I have to do inside. I move it 1 place to the right and pop it up. Now it doesn't matter that we have decimals. So I'm going to rewrite this problem so I'm not getting confused as to where all those numbers are. Then I look, 112 goes into 170 how many times? Goes in once. Again, when I subtract, I can't take 2 from 0, so I have to regroup. 6 minus 1 is 5. 1 minus 1 is 0. Next thing I do is bring down the next number in my set. Now, 112 is about 100. 582 is about 600. But since this is a little more than 100, and this is a little less than 600, we're going to estimate that this probably goes in about 5 times. So I'm going to do the math off to the side to check that theory. And that's as close as I'm going to get. So notice I brought the 2 down. My 5 that I guessed needs to go above the 2. That's really important to make sure your decimal gets in the right spot. This will be 560. When I subtract, I get 22. When I bring down the 4, 112 actually goes in there 2 times to get 224. I have no remainders. I am done. So my problem will be answered 1 and 52 hundredths. All right, let's go on to the next page. Question number 7 is really a little bit more about vocabulary. It's asking us just to label the little pieces that are here. Well, the divisor is the number that we are dividing by. It's the number outside of the house. The dividend is the number inside the house. And the quotient is the answer to a division problem. Number 8 asks us to find the sum. Again, we're dealing with decimals. I'm going to make my structure. 8 goes on this side, and the 92 goes on the other side. 14, remember there's that little magic decimal there, and we're going to fill in our zeros. 2 plus 0 is 2. 9 plus 0 is 9. 8 plus 4 is 12. I carry the 1. 1 plus 1 is 2, and there's my answer. Decimal falls right into place. All right, for the last problem on tonight's homework, which division problem is modeled by that sentence? Well, let's figure out what these fractions are. This is 2 pieces that are shaded out of 6. So this is 2/6. This is 1 piece shaded out of 12. So we're asking 2/6 divided by 1/12 equals. Well, if you look, how many of these little 1/12 pieces can we fit in these 2/6 pieces? Well, if we filled this one, and this one, we would get even. So it takes 4 1/12 pieces to fit into that 2/6 piece. Now, if you were using the keep, change, flip model, we would keep, we would change, we would flip. And flip, I mean we're going to use the reciprocal. So keep, change to multiplication, get the reciprocal. If you notice, these two have a common factor of 6. So I'm going to divide by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. When you multiply across, you're going to get 4 over 1, which equals 4. So either way we look at this problem, we're going to get a 4. All right, that's all for the first half of the study guide. Come back here tomorrow and you'll see the answers to the second half. Good luck, guys.